Cervical cancer detection in pap smear whole side image using convNet with transfer learning and progressive resizing. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share, and subscribe. Cervical intraepithelial neoplasia, or CIN, and cervical cancer are major health problems faced by women worldwide. The conventional Papani-Coulomb pap smear analysis is an effective method to diagnose cervical, premalignant, and malignant conditions by analyzing swab images. Various computer vision techniques can be explored to identify potential precancers and cancerous lesions by analyzing the pap smear image. The majority of existing work cover binary classification approaches using various classifiers and convolution neural networks. However, they suffer from inherent challenges for minute feature extractions and precise classification. The researchers propose a novel methodology to carry out the multi-class classification of cervical cells from whole slide images, or WSI, with optimum feature extractions. The actualization of convNet with transfer learning techniques substantiates meaningful metamorphic diagnosis of neoplastic and pre-neoplastic lesions. As the progressive resizing technique incorporates prior knowledge of the feature hierarchy and can reuse old computation while learning new ones, the model can carry forward the extracted morphological cells feature to subsequent neural network layers iteratively for elusive learning. The progressive resizing technique superimposition and consultation with the transfer learning technique while training the convNet model has shown a substantial performance increase. The proposed binary and multi-class classification methodologies succeeded in achieving benchmark scores on the Helliver dataset. The researchers achieved singular multi-class classification scores for WSI images of the SPI-AKM dataset, that is, accuracy 99.70%, precision 99.70, recall 99.72, F-beta 99.63, and kappa scores 99.31, which subside the scores obtained through principal methodologies. GradCam-based feature interpretation extends enhanced assimilation of the generated results, highlighting the premalignant and malignant lesions by visual localization in the images.